Hello students, welcome to my channel. Here I come with my new video today, and in this video I am going to discuss about applications of trigonometry. In the previous videos we have discussed about trigonometrical ratios, about standard angles, about complementary angles, about trigonometrical identities, right? So based on all this we have solved 4 exercises from Ncert, right? So if you have watched that videos properly, then I think you all are known with the basic concepts of trigonometry, right? So if you know the basic concepts of trigonometry, so with the help of that you will be able to do this exercise, to do this chapter, applications of trigonometry. Okay. Where do we apply trigonometry? If I ask you, where do we apply? If I ask you what is the height of Mount Everest, you will say, sir, height of Mount Everest is 8848 meters. So if I ask you how that height had calculated, it is obvious no one was there who just used the tape, right, the measuring tape, and with the help of that tape they came to know the result that the height of Mount Everest is 8848 meters. No, they haven't used any tape, any measuring tape, right. So how they found out, right, what is the height of Mount Everest? With the help of the section, one of the sections of mathematics, which is trigonometry. So with the help of trigonometry they came to know what is the height of Mount Everest. Okay. So similarly, in case of height and distance, what is the width of a river? How to find width of a river, right? So in all those cases where we are going to deal with heights and distance, there we use trigonometry, and that is not the only application where we apply trigonometry. Okay. Trigonometry is the basic, I can say, is the basic fundamental to know about one section of mathematics which is called as calculus. Okay. In your higher classes you will come to know about what is calculus. Okay. So their concept of trigonometry is required. So but for now we are going to deal with only one application, height and distance of trigonometry. Okay. So let us see, here we have one picture, and what is this? What this picture indicates? This is a theodolite. And what is a theodolite? It is a surveying instrument, and with the help of this instrument, which works on the principle of trigonometry, with the help of this instrument we found what? We use this instrument to find angles, and with the help of that angles we are able to find height and distance of many different things. Like one, we had found the highest peak of the world. During the survey in 1852, the highest mountain in the world was discovered, right, and from a distance of over 160 kilometer the peak was observed from 6 different stations, and with the help of the angle which was found in these 6 different stations, with the help of that angle the highest peak came to known. and it was named after Sir George Everest. It is obvious what we are talking about. We are talking about Mount Everest, right? So, this instrument theodolite was used, and it is still there in Dehradun, in the Museum of the Survey of India in Dehradun. Okay. So, this instrument, the theodolite is used to measure angles, okay, and which is based upon what? It is based upon trigonometry. So, here we have the main application of trigonometry right now, heights and distance. Okay. As I told you in the beginning of this video that the height of Mount Everest, it was calculated with the help of trigonometry. Okay. So, when you are going to apply trigonometry to find out what is the height and distance, right, of a particular object, let it be. So, in that case you need to know few terms regarding that, okay, and that terms are angle of elevation and angle of depression. Now, what is angle of elevation and what is angle of depression? First you need to know that, okay. Now, what is angle of elevation? Let us discuss that. Suppose we have one here we have one monument. I think you all know this monument, Qutub Minar, okay. And suppose if you are standing at the point A, where you are standing? You are standing at the point E, and point A is a point from where you are watching the top of the monument, or you can say your eye. Point A is denoting what? Your point A is denoting your eye, okay. So, from the point A or from your eyes, what you are watching? You are watching top of the monument. What you are watching? You are watching point C. So, this line from point A, from the eyes of the observer to the top of the monument, point C, that line is known as line of sight. What we call it? We call it line of sight, okay. So, the angle formed by the line of sight with the horizontal, here we have horizontal. So, the angle formed by the line of sight with the horizontal is known as angle of elevation, or in other words, when you are watching top of anything, by raising your head you are making an angle, right. That angle is known as angle of elevation. See, here we have one situation. Kite is flying, you are standing on the ground, and from your eye you are watching this kite. So, this this point, that is your eye, and the object, that is the kite, is making an imaginary line. That imaginary line is known as line of sight, and here we have the horizontal. So, the angle formed by the line of sight with the horizontal, that means this angle is known as angle of elevation, okay. Or in short, if you are watching anything from down to up by making an angle, that angle is known as angle of elevation. Now, consider one more situation. Now, you are at the top of a building, okay, and from the balcony you are watching an object. Here we have the object. In that case, where you need to see? Where is the object? It is, in that case you need to raise your head, or you need to below your head. What do you need to do? In this case, what do you need to do? You need to raise your head, or you need to lower your head? Tell me, to see the object. In this case, you need to lower your head. So, when you are lowering your head, when anything is viewed from top to down by making a particular angle with the horizontal, that angle is known as angle of depression, in short. So, see, here is the object and you are watching this object by making this line of sight, this imaginary line of sight. So, the angle made by the line of sight with the horizontal is known as angle of depression, and this angle must be equals to this angle. Why? They are alternate angles. So, when you are watching any object from down to up by making an angle with the line of sight, right, by making an angle here, which here two lines will make an angle, that two lines are line of sight and horizontal, right. So, the line of sight and the horizontal makes an angle when you watch something from down to up or from up to down. Okay. So, from down to up the angle is called angle of elevation, and from up to down the angle is called angle of depression. So, let me show you the exercise which we are going to solve. Here we have exercise 9.1, and in this exercise how many questions we have? See, we have overall 16 questions. So, in one video I am not going to solve this 16 questions, okay, otherwise the duration of this video will become lengthy, right. So, I will solve this exercise by making 2 part or 3 parts, okay, of the videos. Now, let us solve this exercise. Here we have question number 1. In question number 1, what we have? A circus artist is climbing a 20-meter long rope which is tightly stitched and tied from the top of a vertical pole to the ground. So, from the top of a vertical pole to the ground, rope has tied. What we are required to do? Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. See the figure. Here AC is denoting rope, AB is what? AB is pole, and point A is the top of the pole. So, from the top of the pole to the ground, that is the point C. This is what? That the rope has tied, right. So, AC is rope whose length is 20 centimeter, and this rope makes an angle with the horizontal, that angle is 30 degree, and we need to find the value of AB, length of AB. So, let the height of the pole, that is AB, be x meter, the length of the rope AC is 20 centimeter, this angle is 30 degree. Now, you need to consider that trigonometrical ratio where you are going to deal with hypotenuse and perpendicular. See, in this triangle we know length of one side only, which is hypotenuse, and what we are required to find? We need to find the length of perpendicular, that is AB. So, we will consider unknown one with the known one, that means AB and AC, right. As I told you in the beginning of the introduction of trigonometry, that trigonometry is nothing but angle sides measurement. Now, you know one angle and you know one side. So, with the help of this information you can find AB or you can find BC as well, but in this question we need to find AB only. Now, tell me a trigonometrical ratio in which we have perpendicular and hypotenuse. Why I am saying perpendicular and hypotenuse? Because perpendicular is required to find and hypotenuse is given. So, in which trigonometrical we will use which trigonometrical ratio where we have perpendicular and hypotenuse? Sine. Some people have, right. So, if we will use sine, so sine of angle ACB or sine of angle 30 degree is AB by AC, perpendicular divided by hypotenuse, and we know from the chapter of standard angles sine 30 degree is half. So, 1 by 2 is equals to x by 20, and with the help of this equation x is 10 meter. So, see how trigonometry is used to find height of the pole. So, height of the pole is 10 meter. So, let us do the next sum. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground by making an angle 30 degree. So, if we have a tree like this and from a particular point, suppose from this point the tree breaks, then what will happen? Its top, that means this full one, and its top, this one, its top will meet the ground like this. It will not separate. According to this question, the tree is break. The tree has broken due to storm, but it is not separated, right? The top of the tree has not separated from the tree, it just bend. So, see, it's bend and it makes an angle with the ground, and and that angle is 30 degree. So, the distance between the foot of the tree to the point where the top touches the ground is 8 meter. So, this distance is given. What we are required to find? We are required to find height of the tree. So, see the figure first. Without drawing the figure, you will not be able to solve this exercise. So, here AB is the tree, C is the point from where the tree is broken, and its top, that is A, touch the ground at the point D. So, here AC now becomes CD. So, that means this length of this side and this side must be equal. That is why we have AC as x and CD as x in this figure. So, consider here we have AC, that is DC, as x, BC is y, and BD, what is BD? It is the distance between the top of the tree where it touches the ground from the foot of the tree, that is by question 8 meter it is given. Now, see what we need to find? We need to find the height of the tree. So, height of the tree will be x plus y. Now, see this triangle BCD. So, in triangle BCD, first we need to find x and then y, or y then whatever we need to find x and y, simple. Now, so we will find one by one with respect to BD, because BD is known. So, first find x, let us find x. So, here we have base and here we have hypotenuse. Now, tell me a trigonometrical ratio where we have hypotenuse and base. Cos is there, you can use cos or you can use its reciprocal sec. So, sec of this angle, sec 30 degree, it will be sec 30 degree will be hypotenuse divided by base. So, CD by BD, and the value of sec 30 degree, you know, the value of sec 30 degree is 2 by root 3. So, with the help of this equation, x is 16 by root 3. Similarly, to find y, so y is perpendicular and we know this side BD. So, tell me a trigonometrical ratio where we deal with perpendicular and base. Tan, right? So, tan of this angle is equals to BC by BD, and tan 30 degree is, we know tan 30 degree is 1 by root 3. So, with the help of that equation, y is 8 by root 3. So, what is the height of the tree then? This plus this, 24 by root 3, and after rationalization we have 8 root 3 meter. So, the height of the tree was 8 root 3 meter. Now here we have question number 5, and in this question what we have, a kite is flying at a height 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground, where it is tied to a point on the ground. The inclination of the string with the ground is 60 degree. What we are required to find? We are required to find the length of the string. So see, this is the string, point O is the point where the string is temporarily tied on the ground. B is the temporary position of the kite, P is the temporary position of the kite, of which string is tied to a point Q on the ground, such that angle POQ is 60 degree. By question it is given, where Q is the point just below the kite, that is P, and where the point Q is, it is on the ground. So what is the height according to the question? This is the height, then height of the kite PQ. So by question, height of the kite PQ is 60 meter. We need to find the length of the string, that is PO, and this angle is 60 degree. So tell me a trigonometrical ratio where we have perpendicular and hypotenuse. We have two trigonometrical ratios, sine and its reciprocal cosec. So in triangle POQ, I have used cosec 60 degree. So cosec 60 degree is equals to hypotenuse by perpendicular. So with the help of this information, we have x by 60, and sine 60 degree is root 3 by 2, cosec 60 degree is 2 by root 3, and by cross multiplication we have 20 by root 3, and after rationalization we have 40 root 3. So right now I have solved questions till question number 5. Your task is to do all the questions till question number 5, and in the next video I will solve the rest of the questions. Thank you for watching.